Multipoint STM, exploring the effect of joint speed and the number of focal points on perceived intensity, valence, and arousal in ultrasonic media haptics. Hello, my name is Zhouyang Shen, and I am a first-year PhD student from the University College London under the supervision of the Associate Professor Diego Martinez Plasencia. I worked the paper together with Madhan Kumar Vasudevan, Jan Kučera, and Professor Marianna Obrist from the University College London. The development of the contactless interaction has facilitated the emergence of different technologies for providing appropriate haptic feedback. Ultrasonic media haptic is one type of the technology that have been used throughoutly. Ultrasonic media haptics create haptic feedback with arrays of transducers. By combining multiple transducers together, it is possible to concentrate the acoustic radiation pressure wave to the same position at the same time and create a focal point. However, such high-frequency wave is not in human tactile perceivable range. Thus, different modulation techniques are needed to make the focal point perceivable to humans. There are three main ultrasonic media haptic modulation techniques to create tactile patterns perceivable by humans. The first one is amplitude modulation. This technique works by turning the transducers on and off and vary the pressure of focal point within the skin perceptible frequency, which is close to 500 Hz. The different focal point layout will form different patterns or shapes. The second one is lateral modulation. This technique works by retaining the same pressure but continuously moving the focal point back and forth in lateral paths that form the desired shape. The third technique is spatiotemporal modulation, which is a spatial modulation technique that works differently from the previous two modulation techniques. It involves moving a single focal point along the arbitrary pattern trajectory with constant pressure. This movement makes it possible to recreate complicated shapes while also making the optimal use of power. A multi-point spatiotemporal modulation is recently proposed as an alternative for single-point spatiotemporal modulation. It creates haptic sensation with multiple focal points with the optimal use of power and also the potential of introducing more complicated shapes with multiple focal points. During the literature review, we found that previous study has investigated different modulation parameters introduced by different modulation techniques on users' perceptual and emotional responses towards ultrasonic media haptics using just a single-point spatiotemporal modulation. The lack of study in multi-point spatiotemporal modulation has limited potential perceptions and emotions we can introduce to users and also reduced the controllability we can have on the delivery of desired haptic feedback. It is unclear how the spatiotemporal modulation parameters affect users' perceptual and emotional responses when several focal points are applied. Previous research has also shown that the overall pressure on the different number of focal points were similar. In the GSPAT paper, they also validate that the overall pressure did not vary significantly when a circular shape is rendered up to 4 focal points, which is shown in the figure as Z. Since then claim that the user's perceived intensity is correlated to the overall pressure that is delivered by the focal point, it is possible that the perceived intensity on the different number of focal points should be similar. However, there is currently no study assessed how the involvement of multiple focal points would actually affect users' perceived intensity. In this paper, we conduct a user study to investigate the effect of multi-point spatiotemporal modulation parameters on users' perceptual and emotional responses. We rendered ultrasonic media haptic stimuli with combination of 3 joint speeds and 3 number focal point conditions in a user study on users' perceived intensity, valence, which is the pleasantness, and arousal, which is the emotional activation. In the result, we found that the joint speed does affect users' perceived intensity and arousal. However, no effect was found on valence. The most significant difference in perceived intensity can be found between the speed of 1 and 5 meters per second and the speed of 1 and 10 meters per second, whereas the most significant difference in arousal can be found between the speed of 1 and 5 meters per second. Perceived intensity and arousal reached their peak value when the joint speed was at 5 meters per second, decreasing for other values, particularly for 1 meter per second. This is aligned with the previous observation regarding the effect of joint speed and perceived intensity using single-point spatiotemporal modulation. This also seemed to indicate that the effect of joint speed observed on single-point spatiotemporal modulation also translated to multi-point spatiotemporal modulation. In the study, the effect of number of focal point, we found that the perceived intensity reached its peak value when only one focal point was applied, decreasing gradually with the increasing in the number of focal points, with significant weaker intensity when the number of focal point reaches 3. This result also provides evidence to reject the hypothesis from the GS Park paper that the perceived intensity is actually more related to the pressure of each focal point rather than the summation of their pressures. The increasing in number of focal points also decreased the arousal, particularly between the number of focal points of 1 and 3. This suggests that using more focal points could be an effective way to introducing more calming user experiences. This observation could inspire designers to use ultrasonic emitter haptic with applications that requires emotional rather than the functional feedback. For instance, we can merge ultrasonic emitter haptic with virtual reality music rhythm games, leveraging arousal to enhance the musical interaction experiences. Later, to see the whole picture of how the investigated tactile experiences affected by the traditional spatiotemporal modulation parameter, which is the joint speed, under a different number of focal point condition, we display the combination effect of joint speed and number of focal point on perceived intensity, valence, and arousal. We can observe that the effect of joint speed on perceived intensity, valence, and arousal is similar across different number of focal point condition. This has indicated the reuse of knowledge we learned from the single-point spatiotemporal modulation. Also, it encourages us in reusing this knowledge in facilitate more complicated tactile shapes with multiple focal points applied. We also illustrate the effect of joint speed and number of focal points on users' valence and arousal in a circumplex model. In the circumplex model, the horizontal axis represents valence and the vertical axis represents arousal. The display in the figure shows the distribution of the emotional response for a joint speed of 1 meter per second. The black markers and ellipse indicating the emotional responses under 3 focal points, followed by the blue and red markers indicating the emotional responses under 2 and 1 focal point. We can observe that the markers and the ellipse were in a positive valence and a lower arousal area, and with increasing positive valence area covered with increasing number of focal points. The second figure shows the distribution of emotional responses for a joint speed of 5 meters per second, with markers and ellipse located in a higher arousal, neutral, and positive valence areas, and varying valence area covered with increasing number of focal points. The last figure shows the distribution of emotional responses for a joint speed of 10 meters per second, with markers and ellipse located in a lower arousal and a neutral valence area. The valence rating varies slightly with the increasing number of focal points. All figures have the markers and ellipse located in the lower arousal area when the number of focal points increases. In general, we found that how modulation parameters in single-point spatiotemporal modulation affect the user's perceptual and emotional responses is showing a similar trend when multiple focal points are used. This encourages us in reusing the knowledge and lesson learned in previous research to a new technique. The single-point spatiotemporal modulation should be used when we want to introduce stimuli with high intensity and also emotionally activate users. The multi-point spatiotemporal modulation should be used when we want to introduce a stimuli with mild intensity or help user to relax. While these are the highlights of our findings, for the detailed results, we invite you to read the full paper. We also would be happy to hear your thoughts on the paper or answer any question you may have. Please do not hesitate to contact us. Thank you very much for your attention.